In this video, let's talk about linear transformations to matrix transformations. So we're given a transformation. T of x is equal to row x1 and then row x2 plus x3. So how can we convert that to equivalent matrix transformation of the form T of x is equal to ax? So what we do is we say that A is equal to T of the standard basis vectors up to the number of variables that we have. So E2 and T of E3. So what does this mean? Let's take a look. So E1 in a vector in R3 looks like this, 1, 0, 0. Then E2 looks like this, 0, 1, 0. And E3, as you can expect, would look like this, 0, 0, 1. So then how do we find the transformation of each of these basis vectors? So if we wanted to find the transformation here of E1, we plug in T of 1, 0, 0, and that gives us the answer 1, 0, because x1 is 1, x2 and x3 are both 0. So the first column of A is going to be equal to 1, 0. Now what about the next column? Instead, we put a 1 in for 2 and a 0 for 1 and 3. That's the standard basis vector E2. So what do we get for the result there? Instead, we plug in 0 for 1, so we get a 0 up here, and a 1 for 2, so 1 plus 0 is 1. So our next thing is 0, 1. We try again, and what we get is our standard basic vector 0, 0, 1, E3, and multiplying that, or transforming that, we get x1 is 0 up here, and then x2 plus x3 is 1, 0, 1. Now, instead of transforming and using these standard basis vectors every time, there's a trick that you can notice. We notice that the transformation T of x equals x1 and then x2 plus x3. What do you notice about down here? This is x1, x2, and x3. So in the top row, all you get is this x1 variable right here. In the bottom row, you have x2 and x3, and you just plug in ones for those. So if we're given a transformation like T of x1, x2, x3 equals x1 plus x3 and x2 plus x1, what would you expect our matrix for the equivalent matrix transformation would look like? It would look like this. You'd have a 1 because x1, and then you'd have a 0 because there's no x2. The coefficient of x2 is 0. And then the x3 here would be 1. And then down here, we have x2, no, and we have x1. So 1, 1, 0. And that would be our A. Now, what if we had a transformation where there's coefficients other than zeros and ones? So we had T of x1, x2, x3 equals 4x1 and 7x3. The matrix that we're going to use, A, is going to be equal to 4, 0, 0, 0, 0, 7. So T of x equals ax, where A is this, is going to be equivalent to this transformation. Pretty cool, right?